Okay, now here comes another interesting question. The question number 6. Now, in question number 6, we need to find the de Broglie wavelength of electron orbiting in n is equals to 2. So, we have this formula 2 pi r radius of the nth orbit is equals to n lambda. Now, this is 2 pi. What is the radius of the electron in nth orbit, which is given by radius of the electron in first orbit into n square, should be equal to n into lambda. Now 1 n gets cancelled, so lambda should be 2 into pi is 3.14, and they already given the value of r naught as 0.052 nanometer, and we got n is equals to 2. Now let's plug in all these values and let's figure out the answer. I would like to use a calculator so that I might get some approximate value. I'm getting approximately 0.67 nanometers, which is option 1. So to be precise, I'm getting 0.6532312, but fair enough, it's quite close. Now let's move on to the next question. Question number 7. Now here it is question number 7. So in question number 7, what we have is we have unpolarized light which is incident on the surface. Now what happens is, now the light gets reflected and refracted. Now we got refracted also. Let us show this refracted using some other color. So this is our refracted ray. Now this angle of incidence is also equal to angle of reflection. This is what we call it as first law of reflection. So angle I is equal to angle R, and it is said that the light is incident at a Brewster's angle, a specific angle at which the reflected ray is completely polarized. So we need to choose an option where the reflected ray is completely polarized, and this refracted ray is not completely polarized. The only reflected ray is completely polarized. And also we got this formula, mu is equals to tan I. So what is mu? Mu is given to be 1.73, which is approximately root 3. I can call it as root 3 because mu in question they have given it as 1.73, but 1.73 is approximately equal to root 3. So root 3 is equal to tan I, but tan I is equal to R. This is angle of reflection. So this is what we call it as law of reflection. Angle I is equal to angle R. So which is tan, I will call it as R. R is here angle of reflection, not refraction. So R turns out to be 60 degrees. Because tan 60 is root 3. So this is how we get. So reflected ray is completely polarized and angle of reflection is close to 60 degrees, which is option 4. Fair enough. Now, by the way, this is question number 7. Now let's move on to next question, question number 8. So question number 8 is as follows. Now question number 8 is as follows. There are two similar cars, each one with energy 100 joules and 225 joules, and they have applied brakes, and car A stops 100 meters and car B stops at 1500 meters. Now see, let's write question number here first, and see, whatever the kinetic energy this car there has to be, whatever the work done we are doing using some applied force, that has to be used to change the kinetic energy, and the changing kinetic energy is the initial kinetic energy because the particle is coming to rest at the last. So let's write work done on A, which is force on A, which is FA, into displacement of this is given as how much? 1000. So this is the work done, because work done is force times displacement. By work done by B is FB times displacement is 1500, should be 100 upon this value is 225. So how much is this? This 2 gets cancelled, and we got 5 3s, 5 2s, 3 1s, 3 7s, 21, and 1 5s, 25 3s, 25 4s, 2 1s, 2 2s. So FA upon FE, FB, this turns out to be 2 upon 3. This is your first option. Now let's get to question number 9. Should we use the space here? I will use the space here so that we could save more time. And question number 9, what we have is, we got a resistor, and this resistor, let's call the resistance of this wire is R. Now what we are doing, we are cutting this wire in 8 equal parts. Now if you look carefully, resistance is directly proportional to length. So if you are cutting this whole conductor into 8 equal parts, now you get each part of resistance R by 8. So now I got 8 resistors, each of R by 8. I got 8 resistors, each of R by 8. Now what I am going to do is, now I am going to take 4 of them R by 8 and connect them in parallel. This is R by 8, this is R by 8, this is R by 8. And I am also going to copy the whole set and replicate here. I get R by 8, R by 8, R by 8, R by 8. Now this R by 8, R by 8, R by 8, this is R by 32, and this would be also R by 32. And now these two are in series, which turns out to be 2 times R by 32. What is 2 times R by 32? 2 times of R by 32 should be R by 16. So this should be your answer. Quite easy, not too tough. Now this is all about question number 9. Now next we'll move on to question number 10.